robot dolphin. Well, I'll tell you why, actually. So, do you know how, I bet you guys could probably do a pretty good impression of how a dolphin swims, right? Because I know my daughters do this when they get in the pool. They move the flippers back and forth. So these gliders actually move in a slightly different way. They have a way to change how dense they are. And so do you guys understand what that means? If something is not very dense, and you put it in the water, what happens to it? It floats, exactly. And if you put something really heavy or dense, like a rock in it, what happens? It sinks. So these gliders are really interesting in that they can actually change how dense they are. And so when we put them in the water, they float, but then all by themselves, autonomously, they can change the density so that they sink down and make measurements while they do that. And when they get down to about 1,000 meters, they can change their density and come back up. And so they don't actually move around by flapping like this. And so that's why we don't call them dolphins, although I agree that that's quite catchy. So that's a good question. The main ones that we use measure the temperature of the ocean, and it measures the salinity of the ocean. So it measures how salty the ocean is. And that's kind of important because, remember I just told you that the gliders can change the density? Well, the things that temperature and salinity tell you is how dense the ocean is. So if water is warm, it tends to be at the surface, it's lighter, and if it's cold, it's at the bottom. And if it's fresh, it's light, it's at the surface, and it's salty, and it sinks. And so when we look at how temperature and salinity are distributed throughout the ocean, it tells us somewhat about how the ocean is both moving, and more importantly, how it's moving things in the ocean, like the heat in the ocean, maybe how it's moving chemicals around, and how it's moving food for small animals. So we measure temperature and salinity, and then we do measure things like how much oxygen is in the water. So the ocean dissolves oxygen from the atmosphere and carries that into the ocean. And then kind of the more fun measurements is that we have what we call optical sensors. And this is really neat. What it does is it sends out light into the water while it's in the water. And then there are little phytoplankton in the water. And when they see that light, they fluoresce. Do you guys know what it means to fluoresce? They glow. They give off their own light. So we hit them with light, and they go, woo, and they glow. And we can record that light coming back, and so we can actually measure how much phytoplankton there is in the water. So those are the main things that we measure. Yeah, so the phytoplankton are actually plants, and the way they get their food is just like plants do. They do photosynthesis. So the reason why they fluoresce is that they actually take sunlight from the surface of the ocean and do it that way. And then there are bigger guys called zooplankton that eat the phytoplankton, and then as Ms. Kavanaugh says, it goes right up to whales and big fish and eventually to us. That's right. So we were concerned about that because as you said, a lot of the deployments we've done have been in the Southern Ocean. We've not had any problems with our instruments. The last time we were down there, we put out a different type of robot that actually sits at the surface. And unfortunately, we did have some problems with the batteries on those ones. But so far, we've been very lucky. We're actually going out in December of this year to actually go further south than we've ever been before. We're going to be in a place called the Bellinghausen Sea, which is sort of just near the Antarctic, kind of on the southern side of the Antarctic Peninsula. And so we'll see. I'm a little bit nervous about the batteries there, but we've got our fingers crossed. That's a good question. So the ones that we use right now, they can build them, it takes a couple of months because they have to get the sensors from different companies and they have to put all the parts together. Although, if you actually think about how long it took to develop the glider, that was actually a period of about 10 to 15 years. So this idea of actually putting these types of robots in the water has been around since well before you're born. Even almost before I'm born, but not quite. But say, 30, 40 years ago, people said, wouldn't it be amazing if we didn't have to take the ships out and we could put something in the water that would just go up and down and measure the things that you traditionally do from ships. But it took a long time to develop that. And so I feel like I'm very lucky today because the types of instruments that we use is really building on a lot of hard work by a number of other people. really, some of them dedicated their careers to making these instruments so reliable that we can just take them out and go to Antarctica or other remote places and do this science. You know, you definitely have to work hard, but there's something that's more important, and I actually learned this being when I arrived at Caltech, because the most important thing if you want to be a scientist or you're just interested in science is to be really, really curious. It is just always to ask questions. So I have a daughter who's 2 years old, and she goes, you say anything and she goes, why? I'm like, Lane, it's time to go to school. And she goes, why? And I said, Lena, we gotta get in the car. Why? Right? And then at some point when you guys get older, you stop asking why all the time. And what I would say is most important, when you're thinking about things, always ask why, right? So why are leaves green on the trees? Because you're doing photosynthesis, right? Why does the sun come up in the morning and go down at night? Right? All of these questions that you just kind of get used to, always ask why. And Caltech is a wonderful place because I've never met more curious people at Caltech. They're just really interested in everything, and they're always asking why. And so if you always push yourself to be curious, that's the best way to end up at a place like Caltech. Well, that's a good question. I would guess that there's probably maybe 150 to 200 in the world, so that they're still pretty rare. But we're getting to a point where it's going to be much more common. So one example I'll give, we use these robots that actually can make themselves go up and down, but there are other instruments that just float around. And just in the last 10 years, everybody in the oceanographic community got together and said, wouldn't it be nice if we could put all of these drifting instruments in the water? And it took a little time, but now it's an international effort, so people from lots of different countries got together, and there are now almost 4,000 floats that are drifting through the water, and they actually can come up and down just like our gliders, but you can't control those like we control the gliders. But there are 4,000 of those in the water right now measuring the temperature and salinity of the ocean, and this is actually, for the oceanographers, the most important measurements we have of how the ocean's changing. So actually, on our gliders, we don't have the propulsion. And what I didn't mention that's really interesting is that they have wings, right? And so as they go up and down, instead of going straight up and down, they actually slide through the water like this, and that's how they move from place to place. And instead of going straight up and down, they actually sink at an angle because of their wings. And so they sink that and come back up, and they sort of make a V-shaped pattern through the water. Well, yes, hopefully you don't run into them because they're not supposed to be that close to the coast, but sometimes things go wrong, and we have had, not us personally, but I've had colleagues that have lost theirs and been very sad about that. They lost their instrument. However, 6 months later, the instrument has washed up on shore, and our gliders all have a little sticker on them that says, if you find this, call, and it has my office phone number on it. So if you ever find one, and if it's one of ours, you'll have my phone number, you can give us a call, and we'll come get it from you. Yeah, so these gliders actually, because they don't have any propulsion and they just change their density, they actually move quite slowly. So it's not ideal for a river, which tends to move a lot faster than the ocean does. But we've worked before with just drifting instruments. And we actually have some colleagues at Caltech that are interested in how rivers move sediment, or sort of how the rivers migrate from place to place, and they actually sometimes put instruments in the water that just drift.
Thank you. Yeah, thank you for calling us.
Yeah. Great. You guys made my day when I got your email, so thank you for your interest and everything, and this has been really, really fun.